Alright, so hitting pause for a second on moles, we'll come back to that next week. We have to talk about scientific notation. So the mole is written in scientific notation to save you time. So instead of writing 602 followed by 21 zeros, and every single time we did a math problem you had to write that out, that sucks. So we use scientific notation instead, which is 6.02 times 10 to the 23rd, but that comes with its own special kind of math problems. You have to be able to add, subtract, multiply, and divide numbers in scientific notation, and it's kind of like doing numbers that are fractions, which everyone loves, right? So in this notes, I'm going to go over, how do you write numbers in scientific notation? How do we do math with numbers in scientific notation? Alright, so first, what is scientific notation? It is just a way of writing really, really big numbers, like the mole, or really, really small numbers, like the mass of an atom. We need these numbers because in chemistry, what we're dealing with is very, very tiny things, or a whole lot of tiny things. And so these are really large numbers or really small numbers. So, like I said, we count atoms in moles, and the mole is 6.022 with the 20 zeros after it. Like, that's a lot. Or we can write 6.022. Sometimes people do 6.02, 6.022. I think we'll most often do just 6.02 and leave off that other two. Times 10 to the 23rd. So obviously the second one there is easier. If you had to write all of those zeros every single time you did a math problem, that would get, exhausting. So why use scientific notation? It's just faster for writing out really large or really small numbers, and it is easier to do math. You like multiply on your calculator, like 602, 0.00000000  21 times, and then multiply by, blah, 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 blah. Like, to type all those numbers into a calculator would just be insane. So it is a little bit easier to do math with scientific notation if you know how to do the math. That's what I'm hoping to teach you here. Alright, so scientific notation, first, it has to start with a number between 1 and 10. That is the rule. It has to be a number between 1 and 10. And then the number has to be multiplied by 10 times something. Okay? So two rules here. First number has to be between 1 and 10, and then it has to be times 10 to the something. So here is the format here. N is just your number, but this n needs to be a number between 1 and 10. It can never be smaller than 1. It can never be bigger than 10. Okay? And then this should be any number, if you're converting into scientific notation, I'll show you how to do that. This should be however many times you move the decimal. So, is this number in scientific notation 1.23 times 10 to the 11th? And the answer is... yes, it is. This is a number between 1 and 10. This is times 10 to the power. Looks great. Is this a number in scientific notation? And the answer is no. This is 23.98305. This 23 is not a number between 1 and 10. 23 is greater than 10. So you would have to move the decimal over one space, making it 2.398305 times 10 to the 10th. What about this? Is this a number in scientific notation? And the answer is yes. This is a number in scientific notation. You can have huge numbers of decimal places if you want. That's not a problem. But 4 is a number between 1 and 10, and this is times 10 to the something. How about this? Is this a number in scientific notation? And the answer is no. Okay, this is 98,920. No way that is between 1 and 10. This number is too big. You still need to move the decimal 1, 2, 3, 4 spaces, which is going to change your exponent. Here, you can have negative exponents. This is totally fine. This is not the problem. It's this right here. How about this one? And the answer is no. Okay? 0.0158 is less than 1. And remember, scientific notation always needs to be a number between 1 and 10. And so I would move the decimal over 2 spaces, making it 1.58 times 10. And since I went 1, 2 over here, that's going to subtract 2 over here. So it would be 1.58 times 10 to the second. Alright, here's the steps. Find the decimal. Sometimes there isn't a written decimal, and if it's a whole number, you just kind of assume that the decimal is hanging out there at the end of the whole number. Count how many spaces you're going to have to move the decimal to make the base number between 1 and 10. And if you move the decimal to the left, the exponent is going to be positive. And if you move the decimal to the right, the exponent is going to go down and be negative. Move the decimal and write the number in scientific notation. Remember, n times 10x. N is the number between 1 and 10, and x has to be how many decimal spaces you moved it. Here's an example. So if we have, pretend this isn't here. 2, 1, 0, and then all of these zeros, just again, pretend that's not there right now. So the decimal is implied back here at the back of the number, and so I need to move it forward. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I need to drop the decimal off here, making it 2.1, which is a number between 1 and 10. And I moved it 23 times. So this becomes 2.1 times 10 to the 23rd. And you can just drop the zeros. If it was like 0, 0, 0, and then this was a 1, you would have to write 2.10001. You need to keep your whole numbers, but if they're just zeros, you can drop them. Here, so we're going to move it. 1, 2, 3, 4, 5 spaces, making this 9.2, but it went to the right this time. 5 spaces to the right is a negative exponent, so the answer is 9.2 times 10 to the negative 5. Okay. Here, what is your base number? Just asking for base number. What is it going to be? So again, where are you going to put the decimal? And we're going to put it right here in between the 4 and the 5. So my base number is going to be 4.56. It didn't ask for anything else, so let's leave that alone. 4.56. What's my base number here? I'm going to put the decimal right here between the 6 and the 8, because 6.8 is a number between 1 and 10. And so that's going to be my base number, 6.8. And then here, my base number is going to go, the decimal is going to go right here, and then I'm going to keep all the way through the 4. Okay, so it's going to be 5.004. Remember to keep all your whole numbers. The rest of the zeros you can throw away after you put it in scientific notation. Here I'm going to put the decimal right here between the 7 and the 8, so it'd be 7.84, and I can drop those zeros if I want. Here, decimal goes here. Oh, it's asking me for scientific notation this time. So you would move the decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the decimal would end up here and be 4.56 times 10 to the 14. And then here, the decimal is going to go here between the 6.8, like I said before, and it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so this will be 6.8 times 10 to the negative 13. Remember, when you move to the right, the exponent goes down or is negative. Here, it's going to go here, and then you start back here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then it's going to be 5.004 times 10 to the 12th, and I can throw those zeros away. Here, the number is going to go here, and so this will be 1, 2, 3, 4, 5, 6, 7. So it'd be 7.84 times 10 to the negative 7th. And then here, you got to take the numbers out of scientific notation. So 3.4 times 10 to the 6th, you would move the decimal over 6 times. So this would be 1, and then where there isn't spaces, you have to add zeros. So it's going to be 3, 4 with 5 zeros after it. And so it's going to look like this, 3,400,000. So you just move the decimal, and then remember positives, you'll move the decimal to the right. If it's negative, you'll move the decimal to the left to a very small number. So for this one here, you have 8.96 times 10 to the negative 3, and it asks you to take it out of scientific notation. So it's negative 3. I'm going to be moving my decimal to the left. That's going to be 1 space, and then I need 2 more spaces, 1, 2, so it'll be 0.00896, or it'll look like this. Okay, so that's how you put numbers in and out of scientific notation. Now you got to add. Okay? Adding and subtracting numbers in scientific notation is actually harder than doing multiplication and division. You would think multiplication and division are harder, but it's actually adding and subtracting that are harder. So this is going to take a bit of practice to be able to do. So here we have 2 times 10 to the third plus 3.6 times 10 to the fourth. Okay? Before I can add these numbers, I need to make their exponents the same. This is like adding fractions. If you have, 1 over 4 plus 1 over 5, you can't add them until they're both either 1 over 4 or 1 over 5. You have to convert the fractions. And so we're going to have to do that here. It's a little bit easier here because all we have to do is move the decimal to make these equal to each other. And then you also have a choice here. So 10 to the third, 10 to the fourth. I could make either one of them 10 to the third, or I could make them both 10 to the fourth, but just so you are assured, you will get the same answer either way. So if you convert them both to 10 to the third and then add, you will end up with the same answer as if you made them both 10 to the fourth. It doesn't matter which one you pick. There isn't a right or wrong one. All right, so they're going to make them both fourths. So this one's already a fourth, 3.6 times 10 to the fourth, so that one's done. So this one over here needs to become a fourth, and the way you do that, the way you make the decimal go up, is you move the decimal to the left. To the left goes up, to the right goes down. To the left is going to go up. So that's going to make this 0.2 times 10 to the fourth. And I know right now this isn't in scientific notation, but that's okay because we'll fix it later. So 0.2 times 10 to the fourth plus 3.6 times 10 to the fourth. So now I'm going to add 0.2 plus 3.6, which is what they did here, and they get 3.8 times 10 to the fourth. If you had made them both 10 to the thirds, you would have changed this one, and to make it a third, you would have made it 36 instead of 3.6. And then you would have added 36 plus 2, which would have given you 38 times 10 to the third. And 38 times 10 to the third is not in scientific notation, so you would have had to move the decimal, which would have made it 3.8 times 10 to the fourth. So again, you would have come out with the same answer. So convert them both into the same exponent, and then go ahead and add them, and then make sure your final answer has the right scientific notation. So here is one for you to try. And you can go ahead and pause this video, and then I'll show you how to do it. Okay, so I'm going to solve this problem 2 ways. So that way you can see that you get the same answer regardless of what you pick. So over here for this side, I'm going to pick the 20th. So I'm going to make them both times 10 to the 20th. And so this one is the one that needs to change. So to make the exponent go down, I need to move the decimal to the right. Okay? This is going to give me 34.5 times 10 to the 20th. Sorry about the handwriting there. Okay? And then over here, it's going to stay 2.00. I'll just make that 2.0. And then times 10 to the 20th. Okay? When you're adding these, do not add the exponents. Don't make it 10 to the 40th. The exponent stays the same. You just drop that down. Times 10 to the 20th. It stays the same. Like the bottom of a fraction. If you add 3 over 4 plus 1 over 4, the 4 on the bottom doesn't change. So then here you have 36.5. Okay? This is not in scientific notation, so 36 is not a number between 1 and 10, so I am going to have to move the decimal over 1. This gives me 3.65, and then times 10 to the 21st. Okay? When the decimal goes to the left, the exponent goes up. Okay? Over here, 3.45 plus 10 to the 21, so this time I'm going to make them both equal 21. So this is the one that has to change, and to make this exponent go up, I move the decimal to the left. Okay? This is 3.45 times 10 to the 21 plus 0.20, and I'm just going to drop that other 0, times 10 to the 21st. Okay? And then I add those together, so this gives me 3.65 times 10 to the 21st. And so you can see that it doesn't matter which one you pick, you still end up getting the same answer. So hopefully that's what you got as well. Here we are subtracting. So the rules are pretty similar. You have to make the exponents the same, just like with addition. And then once you have them the same, you go ahead and subtract them, and then just make sure your answer is in scientific notation. So here we have 7 times 10 to the 5th minus 5.2 times 10 to the 4th. Here they chose to make them both equal 10 to the 4th. So to do that, we need to change this one, and we want to make this exponent go down. And to make an exponent go down, again, we go to the right. Left, up, right, down. Okay, so 70 times 10 to the 4th minus 5.2 times 10 to the 4th. 70 minus 5.2 gives me 64.8 times 10 to the 4th. I can't stay with the 64.8 because that is not a number in scientific notation, so the decimal got moved one space to the left. Left goes up, so this is 10 to the 5th. 6.4 times 10 to the 5th. Left, up, right, down. Try and burn that somewhere in your brain. It's going to help you later. Okay, so now it's your turn to try one. So go ahead and subtract these two. I'll go ahead and pause the video here if you want to try working them out on your own, and then I will go over how to solve that. Alright, so let's solve this problem here. So I have a 10 to the 5th and a 10 to the 3rd, so I'm just going to make both of them equal 10 to the 5th. So that means this is the one I need to change. So this is a 10 to the 3rd. If I want it to go up to the 5th, okay, I want to make this 5, I need to move the decimal 2 spaces to the left. Remember, left goes up. So there's 1 and then 2, and so I'm going to be adding a 0 on in front. So this is 9.30 minus 0.0822 times 10 to the 5th. Okay, and so you leave your exponents alone, times 10 to the 5th. Don't change those. And then all you have to do is subtract these numbers, and you can use a calculator if you would like. So this comes out to 9.2178, and then times 10 to the 5th. And this is already in scientific notation. This 9 is a number between 1 and 10, so I don't have to do anything. And so this is the answer you should have gotten. Alright, so now for multiplying, and this looks harder, but it's actually a lot easier. When you are multiplying, you do not have to change the exponents. So move the decimal, make everything equal, then add. I don't have to do that. So all you have to do is multiply the front numbers. This time it's 8 times 9. Multiply them. And then you take your exponents and you add them. So 8 times 9, and then 10 to the 3rd times 10 to the 2nd is the same thing as adding 10 to the 3rd plus 10 to the 2nd. So 8 times 9 is 72. 10 to the 3rd plus 10 to the 2nd is 5. So this gives me 72 times 10 to the 5th. More often than not, your number that you get will not be in scientific notation because you're multiplying, so you will probably need to convert at the end. 72 is not a number between 1 and 10. I move the decimal 1 space to the left, and you remember that going to the left makes the exponent go up. So it is 7.2 times 10 to the 6. Very important that you can remember that. Alright, your turn to try one. You can pause the video here and try it yourself, and then you can resume and see if you got it right. Okay, so with multiplication, you just take your front numbers, 7.1 and 8.34, and you multiply them. So 7.1 times 8.34, and that will give you 59.214. Then you take your exponents, so this would be times 10 to the 22nd, and I would add that to the 17th, the exponent from here. This gives you 22 plus 17 gives you 39. So this gives me a number of 59.214 times 10 to the 39th. Except this number is not in scientific notation. 59 is not a number between 1 and 10. So you know to move the decimal over one space here, giving you 5.9214, and then times 10 to the, and you know the answer because you know that moving the decimal to the left makes your exponent go up. Okay, 40. Okay, so hopefully that's the answer you got. Last one, how to divide. Dividing, like multiplication, is a little bit easier. So here they gave you 69,000 you know, they didn't put it in scientific notation yet. It's right here. 6.9 times 10 to the 4th on top. And then 3 times 10 to the 5th. And you're going to divide these. So you just divide the front numbers, and then you take your exponents and you subtract them. And it's really, really important that you always subtract your exponents top minus bottom. Do not reorder them for size. So in this case, 4 over 5, I do 4 minus 5. I don't reorganize them and say 5 is bigger, so it's 5 minus 4. It has to be top minus bottom, and that's super important because sometimes you do get negative exponents. So here, 6.9 divided by 3 is 2.3, and then you subtract your exponents, top minus bottom. 4 minus 5 gives me negative 1, 2.3 times 10 to the negative 1. So again, top minus bottom, very important there. So here's one for you to try. 4.4 times 10 to the 18th divided by 2.20 times 10 to the 14th. Go ahead and try that, pause this video, and then we'll see if you got it right. Okay, so for this one, you are dividing, and you're going to divide your front number, so it'd be 4.4 divided by 2.2 to 2.20. This gives you 2. And then it is times 10 to the top exponent, 18, minus the bottom exponent, which is 14, and so this gives you 2 times 10 to the 4th, and this is still in scientific notation, so I don't need to move the decimal. Okay, so those are the 4 kinds of problems that you need to be able to do for scientific notation.